Okay, all right. Thank you for coming to this talk. It's Building Advanced Analytics with Azure Databricks. This is not the meetings talk, which I think is in room 4. And so hopefully you're in the right room. So just to introduce myself, I am Lofranco. I am a senior software engineer at Microsoft as part of the commercial software engineering team, and I'm based in Melbourne. And I focus mostly around data, specifically around Spark. So I'm here to present to you around Spark, specifically Azure Databricks. So just a quick survey. Who here has actually used Spark? Okay, we have a few folks, yeah. Who has here has heard of Databricks? Okay, used it a bit, played with it? No? Okay, that's all right. So I'm actually going to start off with some basics first. So you should have some understanding of the key capabilities of Spark and Azure Databricks, specifically Spark on Azure Databricks. And I'm also going to walk you through an advanced analytics workload running on top of Azure Databricks. So here's the agenda. So if you've never done Spark, that's okay. I'm actually going to start from the basics, probably just 10 minutes talking about what Spark, what the internals of Spark, and then I'll move into the meat of the talk, which is Azure Databricks. And I'll be doing this in a way where I'm actually walking you through an actual pipeline that I've built on top of the platform. So without further ado, so if you've ever done some work in the big data space, you probably recognize some of these logos. And the thing that I want you to notice is that it's a very heterogeneous set of tooling. That in order to get any end-to-end pipeline with the big data tooling set, you actually have to learn 4, 5, 6 tools. So if you wanted to do SQL on Hadoop, you probably needed to do Hive. If you needed to do some scripting or ETL, you needed to do Pig. Machine learning, there was Mahout. For streaming, there was Storm and Flink. For graph, there was Giraffe. So in order for a data scientist and a data engineer to actually get something substantially running, they needed to actually write 4 or 5 different write on top of 4 or 5 different frameworks. So enter Apache Spark. So Apache Spark is this unified computing engine which could do everything that you saw in the previous slide. So when Apache Spark came out in 2014, it was fairly groundbreaking in its performance and also its functionality. So you could see that in Apache Spark, it gives you these libraries on top of a set of core unified libraries. So you have Spark SQL. It can do streaming. It has a machine learning library built in out of the box, and it even can do graph. And on top of this, it has a number of language bindings. So Spark is actually written in Scala, so you'd expect that it has a Scala API and a Java API, but it also provides a Python and R API, so for the data scientists in the crowd. You also notice that it's actually built on top of, you also notice it's just a computing engine. So compared to Hadoop, if you're familiar with Hadoop, it's actually a computing engine and a file system. So you have MapReduce and HDFS. Spark is just the computing engine. So lots of the times, folks would actually have Hadoop as in HDFS installed, and they would install Spark on top of it. So Spark can reach into different file systems, as you can see here, blob storage, S3, HBase, and Cassandra, and many other things. Okay, so when Spark was developed and released around in 2014, so it's actually quite relatively new, it was almost pegged as, it was built in response to the limitations of Hadoop MapReduce. So the reason why MapReduce is fairly slow is that every mapper actually has to write intermediary results to disk. So every mapper and reducer has to write intermediate results to disk, in which the next stage actually picks it up. Now Spark actually tries to do most things in memory, which is why it's much faster. And so all narrow transformations in Spark is done exclusively in memory. And the great thing about Spark is also it gives the ability to cache data at a specific set. So you'd imagine lots of the iterative algorithms, especially machine learning algorithms, actually go through your data multiple of times. So by caching your data at specific steps inside your pipeline, Spark doesn't have to reach back into disk. And on top of all these improvements, Spark has been benchmarked to be around 10 to 100 times faster than classic MapReduce. Okay, so digging deeper into the Spark API, so if you've ever done Spark, you probably heard of the RDD, which is the Resilient Distributed Dataset. That's the fundamental building blocks of Spark. And ultimately, all of these API actually compiles down to in an RDD in one shape or form. Now, that was when Spark came out, the version 1.x of Spark. Now, at 2.0 and beyond, Spark came out with the data frame and data set API, which is a higher level abstraction on top of RDDs. Now, the advice moving forward is to use this higher level abstraction because you inherit all the optimization that comes out of the box. You don't get that with the RDD API. And the only reason you would probably use the RDD API is if you find this obscure use case, in which case you can't use the higher level ones. Okay, so here's a slice of a Spark application. The most important part of a Spark application is arguably the driver. So this is your heart of your application. This is where your Spark session lives, and that's essentially your gateway to the Spark cluster. And that's also how you would actually communicate with Spark, where you run your user code and so on. Now, the driver is in charge of analyzing and distributing your job across your cluster and giving your tasks to the executors. The executors are, all they do is literally get some tasks from the driver, execute, report back to their status to the driver. Spark can also work with different cluster managers. So in the wild, you probably find Hadoop Yarn as a very popular way of running Spark, because usually customers would already have a Hadoop installation and just want to install Spark on top of it. But Spark also comes out of the box with its own cluster manager, so you don't have hard dependencies on Hadoop. It also works on top of Apache Mesas, and the fun fact is the creator of Spark is also a co-creator of Apache Mesas, so he's quite a smart dude. Now, the other thing I want to draw your attention to is the data structure. So that's a Spark, that's essentially an RDD or a Spark data frame, depending on which API you're using. And if you're a new developer, a very common pitfall is that you wanna you have pandas or scikit and you're trying to manipulate your Spark data frame, and you find that your libraries don't work with Spark data frame. So the first thing you try to do is actually convert it to a pandas data frame. That's not a good idea. Because you could see here, your pandas data frame is living in the driver. That's one node. And your Spark data frame is literally spread across your cluster. So the moment you convert your Spark data frame into a pandas data frame, you're literally collecting a billion rows back into that one little tiny node. So that's a very common pitfall when you're starting with Spark. It might work with small data sets, but the moment you deploy to production, it almost guaranteed will blow up. Okay, so that's pretty much Spark in a nutshell. I'm just going to shift gears now to Databricks. So what is Databricks? Databricks is essentially a managed Apache Spark platform with a number of tooling built out of the box. It's a first-party service on Azure. It's not something you would spin up from the Azure Marketplace, and it comes with all kinds of integrations with Azure, as you would imagine. So Azure AD, data connectors, it hooks up to your billing, so you have a single pane of glass for your billing, and of course you can also view data on Databricks using Power BI. Now, instead of talking about Databricks, it's actually easier to show it. So I'm just gonna shift to here. Okay, so in order to actually create Azure Databricks, so I'm just here in the Azure portal, and I just literally searched for Azure Databricks. I hit create here, and it shows up this pane. And I just literally, just entered my workspace name, pick my subscription, resource group, location, and there's a pricing tier of different tiers within Databricks. So the standard tier, the premium tier is essentially your standard tier, but with role-based access. So that's pretty much it. So you hit create, it creates a workspace very quickly. And once you get to your workspace, just click OK. The internet's interestingly slow, but you will find this button, just launch workspace, and that will launch this workspace of Azure Databricks. So this is pretty much your Databricks portal. The first thing you want to do in Databricks is actually to create a cluster. So to create a cluster, you just go to Clusters and Create Cluster. And you give your cluster a name, so Lace Cluster. You pick which cluster type you want to actually create. So the high concurrency cluster, if you have a multi-user sort of scenario, standard is for single user. So I'm just going to click the standard. And you can pick different runtimes in your Databricks, Databricks runtime version, so which maps to different Spark versions and different libraries that may come installed. There is a GPU cluster. There's a cluster with GPUs, and there's a CPU-only cluster. And in fact, that beta class version actually wasn't there yesterday, so that's actually quite new. Yeah, so you pick your cluster version, you pick your Python version, so Python 3 is probably a better choice. And here is when you have to know a little bit about the Spark architecture. So you have your driver and your worker. So remember, if the previous slide, you pick your driver size, and you pick a specific VM, your worker size. And the great thing about Databricks is it has this auto-scaling feature, so which is not available in HD Insight if you're familiar with that technology. So Spark Databricks will actually detect if there's any back pressures in your Spark job, and it will automatically scale your cluster depending on the parameters you set here. And the other cool thing is that it has auto-termination, which will literally kill your cluster if it detects that it's idle for a set given amount of time, which is a great feature if you've ever forgot to turn off your HD Insight cluster. You can also customize your cluster by specifying some configuration in Spark, some environment variables. You can tag your cluster for billing purposes. And you can ship your logs to a location within DBFS, which I will talk about in a second. You can also customize your clusters further by specifying an init script, which is basically a bash script, which will run every time your cluster starts. So if there's some obscure library that you want to install, this is probably the way to do it. OK, so I already have a cluster installed, so I'm not going to go through. I'm not actually going to create a cluster there. So the thing with Databricks is that it has this thing called your workspace, which is a list of your notebooks. And if you're ever familiar with Jupyter notebooks, it's very similar. So I have a notebook interface right here. And the second thing that you want to do once you open your notebook is actually attach it to a cluster. So I already have a cluster running, and it's attached. This notebook's attached to that cluster. Now, Databricks exposes the Spark session already through the variable called Spark. And you can see that's my Spark session right there. I can inspect the version of Spark, which is 2.3. And here, I am just creating a simple Spark data frame. So, and just displaying it on Databricks. So Databricks gives this nice sort of table UI out of the box, which you don't necessarily get out from other notebook technologies. You can print the schema. And the great thing about Databricks is that you can also mix and match different languages. So you notice this is a Python notebook. And here, I'm actually going to mix in some Spark SQL. So this command literally just creates a temporary view on top of my data frame. And then I can then use SQL to query my data frame. So if you're more familiar with SQL, you can use Spark SQL within your same notebook. OK, so the other important thing about Spark that you need to realize is how it actually executes. Spark has this thing called transformation and actions. So RDDs are actually immutable. The only way you can change your RDD is actually feed it to a transformation, and it spits out a new RDD, a brand new RDD. So you're effectively creating what you call a DAG of executions, a directed acyclic graph of executions. And then the moment you actually want to view your data, Spark will then execute the graph and then give you your data. So Spark is essentially lazy in that sense. So here, I have my data frame, and I'm just doing a set of transformations. I'm just doing selects, group bys, and average. And Spark hasn't actually executed it. It just says, yep, I got your transformation. I know what I'm supposed to do. And then when I actually do an action where I am collecting back the results, that's when Spark actually executes. Now, this is very important to realize because sometimes you would execute 5, 10 cells, and the bug in your code is actually in cell number 1, and you're already at cell number 10. And then when you trigger the action, you only find out that you've already passed your bug. So that's probably one of the biggest hurdles when you're starting off developing on Spark. OK, so jumping back to my slides. So that was a nice sort of quick overview of Spark and Databricks. OK, so Google actually published this very interesting paper, and it was called The Hidden Technical Depth in ML Systems. And the entire idea is that your ML code is actually this tiny little piece of code in your greater ML production system. And in order to productionize machine learning models, there's actually a lot of more work than just the sexy algorithm that your data scientists produced. So that's essentially the gap that Databricks is trying to solve. So it provides you this unified workspace that makes the productionizing of machine learning models much easier, or at least with less friction. So not only do you get a optimized Databricks Spark runtime, you also get the ability to productionize these notebooks, to create multi-stage pipelines, to schedule it using a job scheduler and some notifications out of the box. And as you saw in the workspace, it gives you this collaborative sort of environment where different data scientists, data engineers, and business analysts could actually use. And not only that, you also get, if you step a little bit backwards, you could also see that Databricks rigs up with all the different Azure services. So it can consume data from Kafka and Event Hubs. It can read data from Cosmos, SQL Data Warehouse, blob storage, and data lake. And you can even orchestrate your Databricks notebooks using Data Factory, which you might want to do if you have some other downstream components that you want to run aside from your Databricks notebooks. And of course, you can also visualize using Power BI. OK, so core concepts. So you've seen clusters, workspaces, and notebooks. The other thing that you probably would want to know about is jobs, which is your Databricks job scheduler, where you can schedule notebooks to run at a specific interval. Tables, which I will go through in a second, which is kind of like Hive, if you're familiar with Hive, where you can define essentially Spark SQL tables and persist them in your Databricks workspace. You can save sensitive keys in the form of Databricks secrets, and you can upload third-party libraries in the form of libraries in Databricks. Now, the other thing that you also want to be aware of is the file system within Databricks. So this is essentially similar to HDFS, but really it's just a layer on top of blob storage as far as Databricks, it's implemented. Now, the great thing about this is that it's not tightly coupled with your cluster, so that if you delete your cluster, your data is still there. So, and Spark Databricks gives you all of these utilities to actually access data in DBFS. You can use it using the different APIs, but it also gives you a CLI and some utilities within your Databricks workspace. OK, so with that, usually the first thing that I do when I spin up a workspace is I actually mount my blob storage. Out of the box, it actually comes with a blob storage with your workspace, but guidance is that you want to actually attach a separate blob storage, or maybe your data is already in this other blob storage that's not, that came with Databricks. OK, so I have here a notebook, and as you can see, the first two lines of code, I'm just retrieving a Databricks secret, which I've defined earlier. So this is my storage account and key. And if let me just first attach that. And if I try to execute this, you'll notice that the storage key is actually going to be redacted there. So when it prints out in your logs, you won't see your key printed out in your logs. Now, this is the command of actually mounting Databricks. So remember dbutils, that was the utility command in the slides. That's available out of the box in your notebook. And I'm just calling the fsmount command. And I'm passing Databricks, my storage account, and all of this configuration. The mount path could be just something like mount.blob storage, which is basically a file folder within your DBFS environment. And then I'm just passing my storage key. And I'm not going to run this because I've already mounted it. And the rest of the notebook is just me downloading the data for the demo. So that's pretty much how easy it is to mount a file system in Databricks. And in order to see that, you actually, Databricks actually provides you with a command line dbfs. So I'm just doing dbfs ls and where I mounted my blob storage. And that should show me the files that are living in blob storage once it returns. but I'll just show you blob storage, which has data and models. So this should return okay. I think the internet's struggling at this point. Perhaps someone's downloading a gigantic Docker image in the other room, but that should return basically, and it will list out the files that you see here. That's pretty much it. Oh, okay, that's me typing. Okay, so moving on. Okay, so for the rest of the slides, I'm actually going to be focusing on the specific data set. It's the KDD 9099 network intrusion data set. It's a fairly common data set used for anomaly detection, network detection. So I'm essentially going to build an anomaly detection pipeline on Azure Databricks. Now, the thing with this data set, I just want to throw it out there at the start, is that it's actually not super representative of the real world, because the anomalies in the data set is actually has more anomalies than the actual normal data, and it's a bit synthetic in that way. But I just chose anomaly detection because it's quite easy to understand intuitively, and without me further explaining it. Okay, so here's the architecture that I'm actually building. So I will go through all of these steps one by one. So you obviously have to load your data, explore your data, train your model, and then you want to actually operationalize your model on Databricks. So in order to load your model, usually lots of people use Spark SQL for their ETL jobs. So Spark SQL is essentially the Spark's interface to working with structured and semi-structured data. So it's built on top of your data frames and datasets API, and it provides you ODBC and JDBC access, as you would imagine. So where that lives in my demo is here, and I'll just jump back to my workspace. And I'll open that notebook. Okay, so here, as you can see, I am just creating, excuse me. This doesn't seem to be showing. Sorry? Oh, do I? Okay. Okay, there you go. All right, sorry. Okay, so basically, okay, I'm just here in my Spark ETL notebook. So I'm just literally creating a set of tables using the create table syntax. And you'll notice that it's very similar to SQL. So here, I'm just specifying all my table definition. And I'm saying it's a CSV file living in blob storage, and it's living in this specific location in blob storage. And you'll notice that that's my mounted path. By specifying a location in my create table statement, it says that this is an external table, just you create a pointer to that specific location. Now, after creating that pointer or an unmanaged table by Spark SQL, I can then create my actual table, and then I'll just load my pointer into that actual table using this statement. And then I'm just dropping my temporary table and refreshing. So it's a fairly simple pattern within Databricks, and I'm doing exactly the same thing with my other data set. So a fairly simple table, just your standard CTest execution. And if I go to the data tab, you could see that all my tables are now loaded. So this is persisted in Spark Databricks. And you can see that you can view your data here. And I just want to show you that okay, I just want to show you that, oh, okay. I think there's just some network issues. Okay, I just wanted to show you that it actually supports handling arrays within tables, so you can actually embed JSON within your values. So it does handle semi-structured data. Okay, so jumping back to the slides. Okay, so this is actually the meat of the talk, which is the machine learning library on top of Spark called MLlib. Now, MLlib comes out of the box with different ML algorithms, as you would imagine, so clustering, classification, regression, and even collaborative filtering. And it also provides you out of the box with different feature extractor and transformation methods. And also, probably the most powerful feature is your ML pipelines, which is very similar to the API that you find in Scikit. So digging deeper into the concepts of MLlib, so you start off with your data frame. So it's built on top of your Spark data frame API. And then you have a set of transformers and estimators. So these are higher level abstractions of the different operations that you can do with your data frame within MLlib. And the idea is, it also has a standard way of passing parameters using a parameter map. And the idea is that you can wrap a set of transformers and estimators in what we call a pipeline. And this pipeline you can take as a unit and then use it to transform your data and compose really fairly complex transformations fairly simply. Now, you might be wondering what's the difference between a transformer and estimator. So a transformer, as you would imagine, is very simple. You would just, it takes in a data frame and transforms it to a new data frame. So probably the most simplest transformer you could think of is a binarizer where it gets a column of values, is anomaly, not anomaly, and it turns it to zeros and ones. An estimator is slightly more complex because it takes a data frame and it spits out a transformer. And the way to think about it is that's actually your model. So you could think you fit an estimator, it spits out a trained model, which is now a transformer, which you can use to make predictions on your data. So that's how you would think about it. Now, almost everything within Spark MLlib is either a transformer or an estimator, probably like 90% of it. So you can see that it's a fairly feature-rich library. But let's say you had some obscure logic or some specific model that wasn't available. It's also fairly extensible. So you can write your own custom transformers and estimators. In fact, Microsoft did exactly that with MML Spark, which is a set of custom transformers and estimators written for data science. So it provides deep learning support on Spark and also other data science tools that they thought was quite useful, which was not available in the built-in MLlib. And there's this thriving community of third-party Spark packages, not just MLlib, but also for the other APIs, which essentially extends Spark, which I encourage you to check out. So, okay, so for the demo, I'm just going to show you how to explore data and actually train your model with Spark MLlib. Okay, so I am back here in Databricks, and I'm just going to load my Explore Data notebook. Okay, so I've already run this notebook, but I'll just walk you through it. So I'm just reading my data, my KDD data, and I'm just displaying my data and investigating it. I can print the schema, checking all the columns. Can do a count. It's a relatively small data set, around 1.7 million rows. And here I'm just doing summary statistics. So count, mean, standard deviation, 25, 50, 75 percentile, and so on. And I'm simply just doing a group by between the anomalous and non-anomalous data points. So you can see that the anomaly data points are actually larger than the actual normal data points. So it's a fairly synthetic data set. It was actually created using real TCP connections, but they literally created the anomalous data points, as you can see here. And I'm just breaking down the different types of anomalous data points into their types, because it's actually broken down, it's actually labeled to different types of anomalies. So the normal data set is actually the highest. And the second one is a Smurf attack, which I'm not a network guru, but apparently that's something, it's kind of like a DDoS attack for intrusion gurus out there. And the rest of them are fairly small data points. So it's a fairly skewed data set in that regard. Now, I'm just going to shift to the training the model. So here I've loaded my different Spark ML libraries and just specifying a bunch of variables on the top, and I'm loading my data, like here. Now I am actually defining now my features, estimators, and transformers. So if you're not a data scientist, that's okay. But if you are, you probably recognize a number of these. So the one-hot encoding, scaling your feature so that it falls within a specific range, and probably labeling changing your feature from strings into numbers and indexing it back to strings. So that's all of these feature estimators and transformers. And you'll notice that I'm actually just defining them. I'm actually not using them yet. Now I can actually compose my pipeline here. So you can see that I have this new pipeline statement, and I'm setting the stages given the different features and estimators and transformers that I defined up top. And here I am calling the fit function. So the pipeline is actually an estimator itself, which has a fit function, which then gives me a transformer, which then I can call transform on. So that's all what this is doing. So I'm transforming my clean DF into this transform DF. And then I'm splitting my data between my train and test set. And that gives me a good sort of training set to start with, to start training my model. So the first model that I'm actually training is a GBT, or gradient boosted tree, binary classification, which will classify if it's anomalous or not anomalous. I'm defining my estimator, aka GBT classifier here. And I'm just calling fit given the data. And now I have my fitted model. And I'm just doing your usual evaluation, which is your area under the curve and so on. And that actually did quite well. I think it did like 99% accuracy. So this data set is it's a fairly trivial data set to fit on. The other thing you can do is actually chain a fairly complex pipeline like you see here. So the previous models, I was actually separating out the data transformation and the model training. You can chain that entire thing into one gigantic pipeline like so. And here I'm just using random forests. And here is where I'm defining all my pipeline stages, fitting the pipeline, and doing my multi-class evaluation. The other thing you can do is cross-validation. So which is basically looping through different folds within your data to actually tune your parameters. And here you can also use cross-validation within pipelines. So that's supported. Now, once a data scientist is finished working and is happy with their model, you can now then save your model into disk using Spark persistence. And here you could see that I'm saving all the models back into blob storage. Now, the great thing about this is that a data scientist could train on a smaller subset of your data or a smaller cluster, and then they could give that persistent model to a data engineer to run in a different cluster. So that's probably another use case. Or it's also great for productionizing models. OK, so now I will just swap to the slides. OK, so we have a trained model sitting in blob storage. Now we're ready to productionize it. There's multiple ways of actually productionizing models. One is in Spark, where you can choose between batch or streaming inference. And another very common way of productionizing machine learning models is actually out of Spark, where you're actually containerizing your model and potentially wrapping a REST service on top of this, and then so that other components can actually call into it. We're going to be talking about the in Spark way of productionizing models. For this is actually a completely separate talk altogether. The only thing that I would point out is that if you are interested in this sort of way of production models, take a look at MLLeap and MLflow, which are great libraries on how you would actually do that, like exporting models in Spark without any Spark dependencies and running it without your Spark libraries. So, yep. OK, so you've seen ML persistence, how you would actually save the model persist it into blob storage. The great feature about this is that a data scientist could write their code in Python, and a data engineer can load the model in Scala. So in the real world, a lot of the times, data scientists would write their code in either Python and R, and a data engineer would have to re-implement everything in a separate language because that's what their production environment is written in. But the great thing about ML persistence is that it's uniform across all the APIs. So if a data engineer is writing in R, Spark R specifically, then they can save it, and the data engineer who's reading it in the Scala API of Spark can read it back in, read back the trained model. The other thing that Spark gives you out of the box is streaming. So structured streaming is the API that you get from Spark. It's a successor of the dstreams API if you've worked with Spark for a while. And the great thing about structured streaming is that the code that you write for batch is almost identical to the code that you write for streaming. And the way to think about it is that in batch, you have a finite data frame, while in streaming, you have an infinitely long data frame, or a data frame at least that gets appended to. So that's how logically you would think about it when you're writing code for structured streaming. Which I think is pretty cool. There's obviously some caveats that not everything that works in batch will work in streaming, but predominantly you'll notice that your code is actually quite similar. Okay, so this is the demo, the model operational part, which I'm going to be demoing. Okay, so first I actually want to show you the job. So here I have a batch and streaming job already scheduled. And in order to schedule jobs in Spark, you just do create job and specify a number of parameters. But I'll just actually investigate my current job here, which is my batch scoring job. Okay, once it actually loads. I might shift to my phone Wi-Fi if this keeps. Sorry for that. Does anyone have questions so far while I'm transferring my connection?
When would you use Spark machine learning over something like Azure ML?
Great question. So Azure Studio, I would say, is great if you're still starting out, because it has that fairly simple interface, the drag and drop GUI. The thing with Spark is that you almost have to write code. So you have to be familiar with the APIs out of the box. So it's fairly advanced. I guess advanced-ish sort of data scientists would use Spark. And the thing with Azure Studio, it has a limitation of the amount of data sets you can actually train on. I think it's around the gigabytes. So you won't be able to train over terabytes of data using the ML Studio service. So it's a great starting point, though. So yeah. Okay. So let me just try to reload my job. Okay, that must have been the thing that I clicked on. Okay, so here I have my batch job that's already scheduled. And you can see that I'm specifying a specific cluster size. So the great thing about Spark jobs is that you can have a cluster tailor fit to that specific job, which is very hard to do if you're running on premises. And you can see that I've scheduled a specific notebook, and I could even pass parameters to that notebook. But for this, I'm not actually passing any parameters. And you have a number of different advanced options like concurrency and that sort of stuff, and timeout. So I'll just load this specific batch scoring job. It's actually quite simple. all I'm doing is just loading some unlabeled data points. For production, you probably want to filter this by when was the last run of this job, but for this demo, I'm just loading it as is. I'm loading my pipeline model. For this, I'm just using my random forest pipeline, which I think was the best pipeline model. And I'm just calling it transform method and saving my results. So super simple notebooks. Don't be afraid of batch job. Like batch jobs are fairly trivial to do. And usually streaming, it's only when you really have that specific use case of that low latency inference. So that's batch, and I'm just going to jump to my streaming demo. But before that, I'll just trigger my actual data generator, so which will actually start streaming. So this one, I'm just literally feeding the data from that unlabeled data frame into event hubs. And my streaming job should then pick that up. So I'll just open this streaming job. And this specific job is actually a continuous job. It doesn't have an end point. And you can see that I ran it last night. And if I open my notebook, so here I'm actually hooking up into Azure Event Hubs. So the key thing to know about this is that you actually need to load a third-party library. And in order to do that, you actually go here, workspace, and I like to put my libraries in the shared folder, and you do create library. And this library, you could specify a specific repository that you're gonna pull from. So for Event Hubs, you need this specific library, which is your Event Hubs Spark library, and then you just say create library. And once you have that library created, you have to attach that to your cluster where your streaming job is gonna run. So flipping back to my job. So here you can see that I'm actually loading up that specific library, and I am retrieving a set of secrets. So my event hub essentially connection details. I'm loading my pipeline model, and I'm setting up my connection string to event hubs. Finally, I just connect to my event hubs by using this command. It's called spark.readStream. And if you're familiar with Spark, to read a non-streaming data source, you just do spark.read. And that gives you a data frame called incoming stream, which is literally a Spark data frame, but it's a streaming Spark data frame. So, and I'm just using all the different commands that you would use almost exactly the same as batch. So I'm just adding a bunch of columns. I'm extracting the body field and adding a watermark and so on. And here I'm just extracting some JSON objects, and I'm actually doing a static join between a data frame that's sitting on my Spark SQL table and the incoming stream. So I'd imagine the incoming stream would just probably have 3 fields, but for this specific scenario, I actually extracted the fields out and just match on a specific ID so that I can actually do an in-stream join between static and streaming data frames. Now, I just use my model to use and call the transform, and I'm just filtering on prediction where it is anomalous. And here, I'm just outputting my anomalous data frames, data points into another event hub, in which case a downstream process can probably act on it, like send an alert or whatever you need to do. So that's pretty much it. So it's fairly simple to actually wire up Spark streaming to event hubs. Okay, so Databricks comes out of the box with a number of developer tooling. So you probably, for the guys who don't like repeating the same thing 3 times using the GUI, don't worry. There's a CLI, which you can script everything out that I've just showed you. And it also comes with the REST API if you can't use the CLI for whatever reason. So you can control your Databricks workspace with this tooling. Now, in fact, I've actually scripted out this entire demo. So if you want to deploy this demo literally and Dockerize the deployment, so literally just run docker run IT and pass it that container, and this will literally spin up the demo completely from scratch. It will prompt you for your login details, so it will prompt you for your Azure subscription, obviously, and ask you where the resource script you want to deploy to, and if you're logged into a number of subscriptions, you can point to a specific subscription, and it will just literally walk through all the scripts to deploy this solution. And I've actually also given a different talk, which is the recommendation engine. This is a very similar talk, but it's less focused on MLlib, and you can also spin up this demo as well, where I'm actually, it's an end-to-end recommendation engine built on top of Azure Databricks. So, and if you're not familiar with Docker, you can also go to the GitHub link and you can deploy it locally, but if you don't know Docker, I highly recommend that you go try it out. Okay, so more resources. Just the Apache Spark website, your Azure Databricks documentation, and this is a great book by the creator of Apache Spark, Matai Zaharia, which basically goes deeper into the Spark details. I highly recommend this book. It was recently released this year, I believe. I just read the pre-release. So, and with that, that's pretty much it. Does anyone have questions?
One of the screens you showed us for training the models.
Yep.
I can see that there was a lot of code written. So I'm just wondering, like, did you get any intelligence while you're writing the code? That's the first question.
Okay. Yep.
It's like, can I do step-by-step debugging?
So you don't get IntelliSense. It's not that great. You can also write in your favorite IDE. So the thing with Spark for Databricks is that you have that CLI endpoint, so you can submit jars or Python packages from your favorite IDE like VS Code. So you're not confined to writing code in the notebook. So you can, by that regard, you can get debugging out of the box depending on what IDE you're using.
Could you repeat the question?
Oh, sorry. The question was, can you do debugging in notebooks? And the first one was IntelliSense. Yep. Anyone else have questions? Yep.
So from a best practice point of view, what would this look like from like a CI/CD type scenario?
That's a great question. In fact, a lot of our clients that we find is struggling with exactly that thing, not necessarily with Spark, but ML in general, like CI/CD in ML. There's actually a great talk that's coming up on Friday called DevOps for ML, or ML for DevOps, which is the last talk of the conference. So I definitely encourage you to go to that. But for CI/CD, because you have your CLI in your endpoint, there's no reason why you can't script out anything that you need to do via the GUI. So you can certainly build a CI/CD pipeline where it automatically trains your model, or let's say it builds a Docker container upon check-in. In fact, the GitHub repos that I have has a very simple CI/CD where it literally rebuilds the Docker container, my deployment Docker container upon every check-in. So that Docker container that you saw up front is always up to date. And yeah, so you can see that I have my little CI/CD pipeline there. It's actually using Azure DevOps Pipelines, which is free unlimited build minutes for public repos. So, anyone else have questions? Awesome. So I guess if no one has questions, that's my talk. Thank you, everyone.